Hey guys, how's it going?
Yes. This is the one.
Yes.
If these five steps, is it okay if we flip-flop the R and the CV between the second and the third step?
Oh, I see. Yeah, that's fine. That's fine. As long as you have them. As long as you have them, I think I'm okay with that. That's fine.
Okay.
Yeah. So let's go and take a look at this one here. So our R, if you want to find R first and then find, but you know what? Here's the thing. Actually, no. And for this reason, I want you to draw in your picture first and put in your critical value first, and then put your R where it goes, so it's consistent with what you were doing before. Because I'm worried that people are going to mess up and flip them. You know what I mean?
Okay.
Yeah. So I really want your step 2 to be the critical value. So then things are not changing, and then it's not something different. I want things to be as consistent as possible from what you guys had in the past. So you guys got an R of 0.445. So it goes in here, which means this is clearly the do not reject region. So you do not reject H naught. Don't forget the H naught. Some of you guys left out H naught in the exam, and you lost half a point every time you did that. So that's, you know, a few times. That adds up. So if you do not reject H naught, then it is not a line. These two knots match up. If you do not reject H naught, it is not a line, and you do not have enough evidence to say that there's a correlation between casino and size and revenue. So remember, those always not here means not there and not there. They all go together, right? Those are all. If you have a not here, you have knots there and there. If it's just do reject, if you do reject, then it would be a line, and then you would have enough evidence. Right, so that's how that works. And then your A was 63.876, and your B was 0.4427. So my Y is equal to 63.876 plus 0.4427x. But since it's not a line, I can't use this to predict. I have a line, but it's useless. It's a worthless line. Is that, you guys following me? So instead, you should use Y bar. What's my best guess when X is 190? Is Y bar. What's my best guess when X is 1,000? Y bar. What's my best guess when X is 0? Y bar. It's always going to be Y bar, right? Because it's not a line. Your data is not a line. Questions on that before we move on? This is number 2 in the quiz, exactly.
Yeah.
And then we're going to move on to, this is the degrees of freedom for that one. We're going to move on to lab problem 6, which is here. So here's lab problem 6. H naught is rho equals 0. H1 is rho is not equal to 0. The critical value, degrees of freedom is going to be 6, and your alpha is 0.05. So my critical value is 0.707. So it's going to be negative and positive 0.707, shade to the outside, shade to the outside. And then my R will be 0.771 from Lin-Reg t-test. I didn't write t-test in there. Lin-Reg t-test of L1, comma L2. And then we're going to go ahead and reject H naught because it's totally in that rejection area, which means that it is a line, which means we do have enough evidence to say there's a correlation between number of fires and acres burned. And then finally, you have your A is negative 31.46 and B is 1.036. So here's my linear regression line. And yes, you can use it because you rejected H naught, right? So it is a line. So 100 fires, this is my X, right? Fires are my X. If you go back to your problem, you'll see fires are X's and Y's is acres burned. So since 100 fires is my X, then I want to say, well, when X is 100, what's my Y? So you're going to put in 100 for X, and you'll get Y is 72.14. Okay, good. Questions about that? Let me put my chat on. Why is my chat not going on? I don't know what's up with my chat. Okay, that's all right. Next. Okay, so now we're going to hop into, so someone wave at me or someone speak up if someone's chatting something, because I can't see my chat. It's blanked out from this. Anyway, so we're going to start in on chapter 11. So grab your chapter 11 notes, which is, if you got the one that hand up to me, it's connected to your chapter 10 notes. It's all one big thing. But it looks like this, if you see it. There we go. Looks like that. Chapter 11 notes. This is the one we're working on. Okay, so it starts off the 11.1 test for goodness of fit. That's the one we're going to be doing first, and today, basically. So the chi-squared statistic is what we're going to be using. Chi-squared looks like this. It's a swoopy thing and then a slash. And chi-squared does not mean x squared. It looks like x squared, but it's not. Chi-squared is the name of it. It's not you find chi, then you square it. It's called chi-squared. I don't know why. It's just that's its name, chi-squared. It's a test to see if what you observe matches something that you expect. So, for example, say I expected 30% A's and 35% B's, and I expected 25% C's and like 5% D's and 5% F's. And then I take a test. How do you guys take tests? And I take a sample. And if my distribution comes out differently than this, then I'd say, well, maybe this assumption is not correct, that I shouldn't be getting 30% A's and 35% B's. But if I take a sample and end up with something that's kind of close, then I'll say, okay, this seems like a reasonable sort of assumption that it should be something like that. So that's kind of what we're doing. We're comparing what we actually get to what we expect to get. What we actually got from the sample to what we expect to get. So there are some examples. First, your data, that your observations has to be from a simple random sample. And the expected value for each category has to be 5 or more. So if it's not 5 or more, then it's just too small. So again, I'll go back to that. So the expected values, each expected value has to be 5 or larger. We'll see. So this is about the bottom third, the top third of your page. Right, are these things here? Maybe Robert, can you go and read them for us? It's okay.
Alone represents the observed frequency of an outcome found by calculating the sample data.
Mm-hmm.
E represents the expected frequency of an outcome found by assuming that the distribution is as claimed. K represents the number of different categories or outcomes. N represents the total number of trials or observed sample value.
Great, thank you. So this is our chi-scores. This is how we calculate our test stat. We'll take every observed value minus the expected value, we square it, and divide by what we expected to get. We do that for every single category, and then we add them all up. That's our chi-square, which is our test stat. That's the number we're going to be comparing. We're using degrees of freedom is number of categories minus 1, so that's a little bit different. But it'll make sense as we kind of go through. So here's a problem. Maybe I will actually pull up this one instead, because otherwise it gives away too much information. Okay. Great. Okay. Vanessa, go ahead and read.
Example, for certain flavors. Allergy outcomes will agency whether consumers have any preference among 5 flavors of the new fruit soda. For example, of 100 people provided the following data. Is there enough evidence to show objective claim that there is
Great. So this is what, so we claim, so this is what we observed. So just put them in, put in your categories, and put in your observed. And then we calculate our expecteds. Please note, observed values always have to be whole numbers. You cannot observe 2.4 children. They say the average family has 2.4 children. You can expect to have 2.4 children, but you can never actually observe someone having 2.4 children. That'd be really disgusting and bloody, right? So your observed are always going to be whole numbers. The expected are the things you calculate. Those can be decimals. So here we're going to calculate our expecteds. So here we're saying the claim is that we're saying that there's no preference. So no preference means that what? They are, there's no preference amongst cherry, orange, strawberry, lime, and grape, then the amount of people that pick them should be the same, right? No preference, they shall be equal, right? They should be random. So I have 100 people, and there's no preference, so 100 people split amongst these 5 categories equally. That will be 100 divided by 5. So here we have, they're equal, 100 divided by 5 categories, 20 in each. That sort of makes sense for folks?
Yeah.
Okay, great, thank you. And then we're going to take a look at our step 1. So our step 1 is that H naught is equal to, is always equals, right? In this case, our observed equal our expected. Our O sub i's equal our E sub i's. In other words, every observed value equals it's expected. So my observed cherries equal my expected cherries. My observed strawberries equal my expected strawberries. My O sub 3 oranges, 16 equals my expected oranges, E sub 3. So like you can think of this as being 1, 2, 3, 4, and 5. So O sub 1 equals E sub 1, O sub 2 equals E sub 2, O sub 3 equals E sub 3. So it's just that is where that one comes from. Yeah. I is, it's a counter. It means like all the possible numbers. So I is like a variable that stands for the 1, the 2, the 3, the 4. So what it works is like you do a sum from I equals 1 to 5. Because you start with 1, you end up with your n, or your number of categories, k. So the first one will be O sub 1 minus E equals E sub 1, and then you'd say O sub 2 equals E sub 2. So you kind of go through, and each one your I increases by 1, because I goes everywhere from 1 to 5. That's how that works. That's where this I comes from. It's used a lot in computing and some other things.
Okay.
Yeah, but it's a counter. I is a counter that counts from 1 to n, for 1 to k in this case, however many you have.
Okay.
It's a label, right? So it stands for like all the different possibilities in the label. All right, so then you find the critical value. So we're going to use the chi-squared table. That's a different table. It's this one right here, chi-squared. And you'll see how we don't get these nice little 0.05s and 0.1s. It's all these weird little things you have to look down inside. So here's 0.05 right here. You can see it inside the chi-squared. Do you guys see it? Everybody look up. Do not confuse it with this back one, 0.005. That'll screw you up and give you the wrong answer. It's right here. So if you want, you can even, on your copy, just cross that out so you don't get confused by that one, because we're not going to use that one. And that'll mess people up a bit. But it's right here, 0.05, right there. And we had 5 categories, right? So 5 categories. So it would be, the number of categories minus 1 would be 4. So if I look at this sheet here, I'm going to say, what's my, so 4, and then my alpha is 0.05, so here it's going to be degrees of freedom 4, Alpha is 0.05, so 9.488 right there. This is the one I'm looking at right there. So it's a little bit different than the other ones, but not too hard. And then look at the picture. See, the picture is not this, it's a hill that goes steep and then it drips off. So this chi-squared, it does this, and so it's not like a regular hill like the normal. It goes really high, steep, and then it drops off slowly. That's how this one goes. So that's what we're going to do with it. It's going to be this hill that goes up really high and then drops off, and we're going to have our 9.488 right in there. We're going to shade to the right. Also notice how it starts at 0. So you look on your note sheet. You guys all had this, right? So you can see if you forget, it starts at 0 and it goes on to infinity. So there are no negatives for chi-squared. It just starts at 0 and then goes on up. So it's only right-tailed always, just right-tailed. But you can look at your little sheet here, your table, and find that if you get lost about it, because you're allowed these tables on the final. You need them actually. All right. So then I'm going to do my compute my test value. So let me take a look at that. I'm going to take every observed value minus the expected, square it, divide by the expected. So here I'm going to do that. I'm going to say, okay, my observed 32 minus the expected. So I'm going to do them. This is number 1, right? So I'm going to go from 1 O sub, O sub I means I'm going to sub every single one, the first, second, third, fourth, and fifth. You don't have to number them. That's what that's what the I's stand for. The I goes from 1 to 5. So it's going to be 32 minus 20 squared divided by 20. That's the first one. That's this guy right there. And then the next one, 28 minus 20 squared divided by 20, my expected. And then you're going to do orange and lime and grape. And then you're going to add them all up. And if you add them all up, you'll get 18.0. You don't have to do it in a calculator now. Just go ahead and write it all out. This is going in the bottom of your first page, front page, test statistic, right? So just write that formula all along that line there, and we should be good. Let me know when you guys are done. Maybe another 10 seconds. Okay, so let's go ahead and move on. Yeah, yes.
Could you go back to step 1 for a second?
Sure. It's the observed values equal the expected values.
Oh, okay. Page 5 of each one.
Yeah. Sure. And then step 2, again, find your critical value. Draw a picture. Step 3, compute your test value, your test stat. So it's going to be this right here. We're going to get 18. So we're going to throw 18 into this swoopy thing from part 2. Step what? This one?
Yeah.
Okay. Sure.
Professor Young, why isn't it like positive negative for the critical?
Because chi-squared start at 0, and chi-squareds are never negative. They start at 0, and then they go on from there. I don't know why. That's how this chi-squared distribution works. It's never negative. So you start off at here, and it just goes up, and then it goes straight out to positive infinity. It only goes in one direction. And y is certainly beyond the scope of this class, for sure. I mean, if you really want to know, I can go back and ask some folks and maybe look it up and try to sort it out. Okay, so you can see it's clearly in the rejection region, right? So step 4, we're going to reject H naught. And then we have a better answer up ahead. Okay, you guys ready? I'm going to move on. I'll come back to this in a minute. And then here's a summary of the results. So There is enough evidence to reject the claim, so pretty much you're going to be looking at reject for your claim for 11.1 and 11.2. 11.3 is the means are the same. Probably for all of chapter 11. So yeah, just use if you use the word reject here for all of chapter 11, then we'll be in good shape. That'll be perfect. So for chapter 11 will always be reject. So chapter 11, claim should always be reject. And certainly on the exam, they will always be reject. Your homework might do weird things because it does that sometimes. But in terms of the stuff I give you on the exam, it'll always be reject. Yeah.
I was just like kind of confused on the point I'm finding
The 9.488?
No.
Oh, yeah, because it's saying that 95% of the data is going to. This is my critical value, right? So 95% of the data will lie over here, and 5% of your data is going to lie over here. That's how this critical value gets picked, because my alpha is 0.05, right? So that means 5% is in the tail, 95% is here. That's a great question. I'm so glad you asked that. That's super cool. Yeah, no one's ever asked that before. Critical value is exactly. So whatever this amount here is alpha, whatever your alpha is, in this case it's 5%, so then you find the critical value based upon that. And it'll change a little bit depending on what your degrees of freedom is, right? So the degrees of freedom, these are all alphas 5%. As your degrees of freedom becomes bigger, and as you have more categories, then you're going to be adding more and more stuff, so they kind of adjust for that. And these become larger and larger. Because this is, remember, the number of categories minus 1. So if you have 4 categories like we did, then you should have around 9.5. But if you add another category, you're going to be adding more things to it. Right? You're going to add, if you go back to this step here, right, you're going to add 1 for every category you have. So the more categories, the bigger this becomes, because you're adding another number in there. So, you know, obviously the more and more categories, it has to become larger and larger. Okay. One other thing. Yes, go ahead. It is exactly. It's the number of categories, because we only have one type of category. We only have categories. We only have fruit flavors. That's it. So we'll see something a little bit different next class. But yes, so it's number of categories minus 1. Because we only have one thing. We only have fruit flavors. That's it. So fruit flavors minus 1. So here's an alternative way of computing this. You can use your calculator. So let me show you how you do that one. So here, if you want. Now, honestly, I'm only going to give you at most 4 items, 4 categories on the exam. So it's just as easy to do it by hand. So here we've got stat, edit, and I'm going to put my observes into list 1. So 32, 28, 16, 14, and 10. And my expected 20s are all 20s in list 2. Now what I want is, I'm going to clear this. What I want is observed minus expecteds squared divided by my expecteds. So what I want is list 1 minus list 2, right? Oh, observed, here I'll show you. My observed are L1s, so I'll put L1 in here. My E's, my expected are list 2, so I'll put L2 here and here. So I'll have L1 minus L2 squared, so you can see this down here, squared, divided by my expected, which is L2 divided by L2. So this is what I'm going to type into my calculator. And it should be on your sheet as well. So I'm going to go up so my cursor's on the L3, and then I can type it in. Second L1 minus, ooh, I got a parentheses around it though. Oh, I forgot the parentheses. So parentheses, second L1, if you don't put the parentheses, you're going to get something totally wrong, minus second L2, and you should use the subtraction here. Don't use the negative sign, use the subtraction sign. End parentheses, raised to the second power, so caret second power, divided by second L2. If it doesn't look exactly like this, if you forget the parentheses, then you're going to have big trouble and it won't be right. So as soon as I hit enter, it's going to multiply all those for me at once. So boom. That's all those individual values I got. So if I look at this one here, then this calculator, these are all those numbers. That first one, this is 7.2, this is 3.2, this is 0.8, this is 1.8, and this is 5. And then I need to add them all up, right? So I need to sum list 3, so you can do stat, calc, 1var stats of 1var stats of list 3, sorry, second L3. The only reason why I don't like doing the calculator for this one is because it's too easy to put list 1 here and get the total wrong answer. So I think it's just as easy just to do this by hand because it's not that many. It's only going to be like 4. But that does give you your sum of your x's, 18. So you'll see down here. Yeah, go ahead.
So just if I was asking you, what do we put it just when we do the like L1 minus L2 squared, like which function?
It's not. It's in your lists. So it's just stat edit to get into your lists.
So we're just using
the list. Nope. Nope, not at all. So so when you do stat edit, and you have to go up, so you're actually on the L3. You have to be inside your cursor, your little, see where it's sort of the cursor's on the L3? Has to be on the L3. If you do it down here, it's going to give you an error. So you can't do a formula here. You have to be in the L3 itself, and then you can do it, and then I'll put it into here. And then you add them, you sum them up. Make sure you do stat calc of L3, not of L1, because people always mess that up. So that's why I kind of recommend, I think students are better off just doing it by hand, because there's only going to be 4 of them, maybe even 3 of them. So it's just easier to not run that risk. Okay. If you add them up, you get 18. Either way, you get 18. That's your test stat.
Okay.
Right, because list 3 is a whole bunch of numbers. If you look at list 3, it's all these numbers. You have to add them all up. This is not your answer. You got to add them up. That's your answer. That's your chi-squared.
When I did that, when I did in parentheses L1 minus L2 squared, I didn't get what you got.
Did you divide by?
Yeah, there we go. That's
yeah. Okay. So let's take a look at this one here. So again, remember, our observed, we just give them to you. You just write them down. It's what they observe. It's what you got from your sample. And they tell you what they are, you write them in. The expected, the E's, are the ones you calculate. Those are the ones that can be decimals. What you observe always has to be whole numbers. You have to observe a whole person doing something. You can't observe half a person doing one thing and half a person doing something else. It has to be the whole person. The whole person picked grape. So your observers are always going to be whole numbers. Your expecteds, though, those you calculate, so they absolutely can be fractions or decimals. So here's the thing. If the expected frequencies are not equal, in other words, like remember I had before I said, oh, I think that, hold on. I think that, 20% of you, 30% will get, we'll say, 10% will be D's, right? And then 20% will be C's, whatever. I have to calculate how many that will be, because it's got to be the number of people that are observed. So how many would that be? 10% of what? 10% of N. Or 20% of what? 20% of N. So you multiply your N times your P, and that'll give you your expected values. Now, if all expected frequencies are equal, in other words, like that sort of thing where we had 100 people, we expected them all to be the same, then we just take our N, how many we have. We surveyed 100 people. We have 5 categories. We split them evenly amongst the 5 categories, right? So the number of categories. So you just divide by whatever your number of categories is. So let me ask you guys this. I flip a coin 5 times. What are my categories? When I flip a coin, what could I get? Heads and tails? Well, we could get heads or tails. Does that make sense? So how many categories do I have? 2. Great. What's the probability of getting a head? If I flip a coin. 0.5. Tails? 0.5. Great. How many heads do you expect to get if I flip a coin 5 times? If you flip a coin 5 times, how many heads do you expect to get? 2.5, right? Where does that come from? It comes from multiplying N by 1 over K, or taking N and dividing by K. 5 halves. 5 halves is 2.5. So again, remember, expected frequencies do not have to be whole numbers. They can absolutely be decimals like this, 2.5. But the observed outcomes always have to be whole numbers, because those are based upon experiments, what you actually observe. All right, so here's an example. Let's get someone to read this one. I already made him read. Ian, go ahead and read.
The census Bureau of the U.S. government found that 30% of adults did not finish high school. 30% graduated from high school. Only 29% had some college education but did not obtain a bachelor's degree. And 28% were college graduates. These proportions were consistent with those people who lived in the Lincoln County area. The local researchers collected a random sample of 300 adults and found that 43 did not finish high school, 76 were high school graduates only, 96 had some college education, and 85 were college graduates. I forgot what
Alpha? Alpha?
Alpha is equal to 0.9. That's a claim that the proportions are the same for the adults in Lincoln County as are the same by the Census Bureau. Perfect.
So first I have to figure out my categories. I've got 13% did not finish high school, so no high school. 30% graduated from high school, so that's HS. 29% had some college, SC, and 28 were college graduates, so college. Those are my categories. And then put in your observeds. My observeds were, and hey guys, heads up. On the homework, it's going to try to screw you. On the homework, they're going to mix this up. So they're going to put in like college first, so you have to fill in this last one first, and then they'll put in high school second, so you have to kind of pay attention. Do not just go with the order they give it to you, matching up with these things, because they're going to mix it up on you and put them out of order on the homework. So pay attention to that so you don't spend hours, like literally one student spent 3 hours trying to work on this one problem, and it's because she didn't realize that they had switched the order around. So they give it in one order up here, and then later on they give it in a different order down here, and you got to move it around. So here I had 43 of them did not finish high school, 76 were high school only, 96 had some college, and 85 were college graduates. So here's my numbers here. So now I'm going to say, okay, my expecteds. So let's see what my expected should be maybe. So my expecteds, let me put them up above here just for a second. So my expected high school, no high school, 13%, so 0.13. And then high school was 0.30. And then some college, 0.29, and college, 0.28. Make those decimals, maybe I should try to put, oh, that didn't work. Sorry. So is it fair to compare 43 to 0.13 and 76 to 0.30 and 96 to 0.29? That's totally not fair. That's a completely unfair comparison. Do you guys see what I'm saying? I can't compare 85 to 0.28. That's not a fair comparison. This is like totally wrong. So what I need to compare is this is 28% of what? 28% of 300, right? So I need to compare apples to apples, people to people. So what I need to do is find 13% of 300, 30% of 300, 29% of 300. So of again means multiply. So 13% times 300, 39, 30% times 300, 90, 29% times 300, which is 87, and 28% times 0.84, which, 28% times 300, which is 84 people. So now compare, if I expected 13% of these people, so I expected 39. Does that kind of make sense? 30 people, I expect about 90. I expect about 30% of them, about 90 of them will be high school graduates. So that's kind of where those numbers come from. All right, so then we go through our steps. Step 1, H naught, again, O sub I equals E sub I. That's going to be my claim for these ones. H1 is going to be O sub I is not equal to E sub I. So this is you're filling this out on page 2. This is one we're turning in today. All right, this is your work you're turning in today. Example. So the stuff we did earlier and this one, my critical value is, let's see, bust out my table. It's going to be alpha's 10%, and I had 4 categories. So my degrees of freedom is going to be 3. I'm looking at the third row, and then alpha's 0.10. It's right here. So it's going to be this column, third one down, 6.251. That's what I'm going to get. So 6.251. Draw your picture. Steep up and then slip off slowly. 6.251. Then I'm going to find my test stat. So I'm going to take every single value minus what I expected, so 43, oops, minus 39 squared divided by 39. 76 minus 90 squared divided by 90. 96 minus 87 squared divided by 87. 85 minus 84 squared divided by 84. So this needs to be, I need to fix that because that was hard to read. That's a 90. All right, so when I do all these, I'll end up getting, this is 0.410, this is 2.18. Do you guys want me to show you on the calculator quickly? So I'll go ahead and clear. Let me get out of here. 43 minus 39, enter. And I'm going to raise that to the second power, enter, and I'm going to divide by 39. So that's my first one, 0.410. And then I'm going to do the next one, 76 minus 90, enter, raise it to the second power, 196, and then I'm going to divide by 90. So that's the next one, 2.1777, 2.18. And then the next one, 96 minus 84, enter, squared divided by 87. Oh, that's not right. 96 minus, oh, maybe I screwed something up. 96. Yeah, what did I do? Oh, 84? Ah, got it. I got it. Yeah. So it should be, if I did it correctly, it would have been 9.931. And then 85 minus 84 squared is just 1 divided by 84. Oh, divided by 84. 1 divided by 84. That's upon the calculator. So 0.012. If you add all those up, you'll get 3.531. So then we take a look at our little area here, and we'll say, oh, if I look at that, then that is clearly in the not guilty range. So I'm going to not reject H0. Do not reject H0, which means we do not have enough evidence to reject the claim that percentages are as stated. And you just do it like that. To reject claim, you just leave this all the same. Evidence to reject claim that percentages are as stated. That's fine. You can just use that generically. I don't care about this one. And we're just going to, like I said, we're covering these chapters very, very lightly. You can just verbatim say blank evidence to reject claim that percentages are as stated. And it'll either be not enough or enough. That would be the only thing that changes. All right, so you guys have 5 minutes left. I'm going to throw you guys into your rooms. You have 5 minutes to work on lab problem number 1. And a couple quick notes about it. Maybe. Oops. Oh, here it is better. They did a little better words. Here's a summary of it all. Right here are your 5 steps. So find your H0 and H1. Find your critical value from the chi-squared table. Calculate your test stat. Chi-squared is your test stat, so it's using these. And then decide if you're going to reject the null hypothesis, and then summarize your findings for your claim. So this one, so here we have our observed, right? We've got our 62 accidental, 23 homicides, 5 suicides. Do your observed first, because that'll kind of anchor you. And then figure out what should go for the expecteds after that. Compute all those. So I have to add them all up. If I add up 62 plus 23 plus 5, I get 90, so that's my n. So 74% of 90, that would be my expected here. 16% of 90, that would be my expected there. And it's going to be decimals. 74% of 90 is going to be some sort of decimal. So this is 62, right? And then 74.74 times 90 is 66.6. So these, again, the expecteds will not always be whole numbers. Very often they'll be fractions or decimals. All right, so I'm going to pop you guys into your groups. Just go ahead and work on it for 5 minutes, 3 or 4 minutes. I'm going to go and say goodbye to you guys now, because I'm going to probably open up my, well, we'll see, actually. I'll probably be around. I'm not going anywhere. I'll be here for a little bit. So I'll probably break you guys back out of there, and I'll probably close the rooms in 8 minutes, but I'll give you guys extra time if you guys want to work on it together.